Good morning, everyone. I'm Yang Chen from Microquanta, China. Today, I want to take you with me with a short journey we have did in Microquanta, how we're bridging the gap between lab research to fully commercial utilization of perovskite solar. We founded in 2015 in Hangzhou, China, and in 2018 we did our 20 megawatt pilot line. 4 years later is our first 100 megawatts production line, and until today we have 100 megawatts production line, 20 megawatts tandem line, and then by the end of this year we are looking at to have 1 gigawatt production line, finish the equipment installation, and hope to have the pilot production. You can see from the picture that our production line is fully automatic and specifically designed for perovskite solar, not adapted from silicon solar. And on the right side, you see the big building block is actually our 1 gigawatt production line there, and on the side is what we currently have. We have been leading this game about the efficiency. Our first world record comes in 2017. It's 15.24% on a mini module. And until today, we have 14 world record for perovskite module efficiency. In 2023, that's a big year turning point for our commercial series. It had been certified with IEC test, IEC 61215, IEC 1730, and IEC 63209 series, certified by VDE and CQC. That marks perovskite solar has been truly ready for commercial use. We have installed more than 30 megawatt projects across China in different environments, different scenarios for different kind of applications. Some special projects like what we did is this one is a large, actually it's a skylight dome using our transparent panels. This is one of our highlight projects. It is 86 megawatt agrivoltaic project. We did it in Songyang, Zhejiang, China. It finished in November 2024, and it's the largest of its kind. We are very proud that we finished this project. Besides the power plants, we also have the BIPV product lines. For the BIPV product lines, we have the transparent series. The transparency can be from 20% to 60%. And for the color series, the color tones and finishes can be adjusted up on the request to match the building for the integration and aesthetics. The size of the panels can go up to 2 meters by 2.5 meters, which is perfect for building facade. It can also integrate with insulation, low E coating, and anti-glare, have multiple features of this PV glass. We have done projects like for public buildings, universities, commercial buildings, factories, elementary schools, residential uses, so on. Since we all know that in the lab, perovskite solar cells have achieved more than 27% of the efficiency, but when it comes to the scaling up, we really have challenges. At Microquanta, we tackle this problem systematically by developing equipment and processes. This is how it actually looks like in our production line. At first, the substrate will go through the slot die coating process to create an even film, and then go through the laminar air dryer, the light drying process, and then finally it's going through the vacuum annealing process at about 20 minutes to finish the crystallization and locks in the stability. To tackle the challenge that to form an even and distribution wet film on this large-scale glass substrate, we redesigned the coating head. By utilizing the finite element simulation, we redesigned this geometry and functional of this coating head, and you can see from the red pictures, gradually we refined and everything and to get the uniform distribution. So after simulation, we went ahead to production. At first, we did a 3D printed prototype and to study the geometry, do some final refinement, and then we moved to have this metal equipment integrated into our production line, and you can see from the picture that this is how it actually looks like today in production. One of the biggest breakthroughs for us is to understand the drying quality for perovskite solar. And comparing to vacuum flash, which will cause uneven drying and solvent will trap into this crystallization process, our lead dryer will achieve clean uniform fumes with stable airflow. And here you can see on the right, it's after UV exposure, the lead dryer still retains 98% power, while the vacuum flash drops to 70%. And on the left, I want to mention a little bit here is you can see it's basically the light dryer recreates the spin coating quality of evenness of this fume. We want to get the best result, and then we did some further work to refine and optimize the design of the light dryer. We finally ended up with this final design on the right. So it gives us uniform laminar airflow across the square meter level substrate, and prevents edge turbulence and uneven solvent evaporation. And on the pictures, you can see that the quality of this design. Here are some results we have from this lead dryer. For the PL image, you can see most of the dark spots are gone, and it looks perfect. And in the middle is we did a 1-year outdoor test, and we found that only 2% of the efficiency is lost. And on the right side is we had like a 135 watts module with 19.48% efficiency with a grid fill factor at 0.78. Then we moved ahead with factory validation. We had a 15-day continuous run with average voltage is 111 watts, which equals to 14% efficiency. And we found the lab process is very stable. 98.5% of the modules are within this plus and minus 2.5% power variation range, and the Champagne module is 18 watts. All of the modules produced were fully compliant with the IEC test. Here are what we have by comparison with silicon. So we installed 2 rooftop systems in Quzhou, China, 500 kilowatts perovskite and around 5 megawatts PERC silicon. For the perovskite, the efficiency is 14%. For the PERC, the efficiency is around 21%. We monitored for about 1 year, and to have a better and fair comparison, we installed perovskite modules and silicon modules into different inverters, and we use this equivalent full sun hours to establish a fair comparison. It's a normalized energy metric, so we compare the energy yield per installed kilowatt. What we found here is perovskite actually generates 30% more energy than silicon, even at lower efficiency. So, and also it means 27% in cool months and 32% more in warmer months. And the driving factor behind this is perovskite has really great temperature coefficient and low light response. Some of these findings are summarized in our science paper. We demonstrate that there's a strong correlation between UV exposure, temperature, and long-term stability. And looking ahead, we are looking to expand this LED process to larger module, which is 1.2 meters by 2.4 meters. And for this tandem modules, we are doing 40 configuration. We want to push this efficiency above 30%. In the picture, you can see that's our first tandem installation, which is 500 kilowatts. And we want to install perovskite solar. We want to introduce our panels across the world to install them in different climates and locations. Thank you very much.
Thank you, Yang Chen from Microquanta. Very interesting. So who wants to go first? with questions? Over here.
Hi, Yang. Thanks. Very nice talk. I'm Mehul from RCD Solutions. So there's been some study that during the winters, the perovskite performance is going down. But from the graph that you showed, it seems it's very good also in Kubushi, which is also close to 0, -5. I saw the temperature variations. So do you observe any change in the perovskite performance in hot climates, very cold, where there's significant difference in the performance, in the efficiency?
The temperature is definitely a driving factor to impact the perovskite solar, but also we have to consider that Kubuchi has really great solar radiation there, and comparing to Chido site. So yes.
Okay, thanks.
Thank you.
Thanks.
All right, one more question.
Yeah, thank you. Very nice talk, first of all. Thanks a lot for sharing so much of details, which is mostly missing in company presentations. But my question is straightforward for like almost all perovskite companies. Can we place an order?
Yes,
Like if you want to buy, can we buy it?
Yes. How many business cards do you need? I have like multiple, and I have more in my backpack.
Oh, that's perfect. No, that's a litmus test. If it's ready, we can buy. As a consumer.
It's ready. We offer 25 years production warranty and 12-year product warranty. For the first year, you are looking at the degradation at 2%, and then after that, each year you are looking at the degradation at 0.7%.
Yeah, thank you. Thanks a lot.
All right, then one more question here in the back.
Yeah, hello, Yang. We know each other from Solar Innovations and BIPV Law of Just Solar Architecture. For me, of course, opportunities in architecture are the most interesting thing. As you know, this is my passion. Yeah?
Sure.
And so I saw a video which you sent to me, and there is a high transparency for street barriers.
Mm.
How you create that, and how is the efficiency or the power in these panels?
The power density for this kind of like, those are the panel we're using in that video. I know what you're talking about is our transparent panel at 40% transmissions. The energy density you are looking at is around 55 watts per square meter. So we actually installed them horizontally and make the connectors connect to each other, and then there's going to be a combiner box and then the inverter. For everything, for everyone else don't know what I'm talking about, please go to my LinkedIn page. I have a wonderful video there and showing the application for perovskite, how it can be using as balcony applications or like a fence applications using transparent panels.
All right, thank you. Then let's thank Yang Chen again.